Good morning. Uh, I'm very happy to be here for presenting my achievement report. Firstly, I would like to say very many thanks to IITA organization for giving me these opportunities. And now I would like to introduce a little bit about myself. My name is Hoang, and I come from RFME lab. My professor is Professor Lee Sang-kuk. And I received the IITA scholarship from 2004. And here, let me introduce a little bit about my biography. I was born in Bắc Ninh, Vietnam in 1978. And I received the BS degree from Hanoi University of Technology in 2001. And after that, I came to Korea. And I received my master degree in Information and Communication University in Daejeon in 2004. And now I am towards my PhD degree in Information and Communication University. And now I would like to introduce about my research work. Next one. From 2002 until now, I have been engaged in the silicon technology-based analog circuit design, such as the bias reference circuits, the variable gain amplifier, automatic gain control amplifier, chance impedance amplifier, low-pass filter, and baseband transceiver. And my current research interest includes the wake-up receiver for sensor networks and buffer for LCD drivers. And about my research achievement, we have successfully designed the variable gain amplifier that have significant impact on the world's VGA. And in this work, we have proposed many ideas to approximate the exponential characteristics, which is one of the most important characteristics of the VGA. And with our proposed idea, we have to reduce the cost of the commercial product VGA by at least 4 times. So it is a huge improvement in this area. And our VGA has been used in many applications, like the telecommunication, image processing, disk drivers, and medical equipment, and so on. The VGA in our work has been embedded in Zigbee transceiver design from 2004 until now, and wireless LAN transceivers in 2005, and UWB transceiver in 2005, and so on. Next, please. Also, we have successfully designed the bias. This circuit is very compact for use in LCD driver. This work has been done and fine. While I am in Silicon's work company, this is a very big company supporting about LCD driver. And this circuit will be embedded in the products of LCD driver. With the very compact characteristics of our proposed circuit, it will help to reduce the power consumption and also the cost of the commercial products. And we also successfully designed the baseband circuits for Zigbee transceiver. This kind of transceiver can be used for many applications. And this work has been done from 2004 until 2006. With this successful implementation of the baseband circuits with very low power consumption and chip size, our work can be very useful for very low power commercial transceiver product for use in portable telecommunication systems. Next, please. And now I would like to talk about my achievement in terms of papers. Until now, I have two journal papers. One is presented as the IEE electronic letters in 2004, and the other one is presented in IEEE transaction on circuit and system in 2006. And also we have 7 journal papers under submitted for publications. For the conference paper, we have published more than 15 international conference papers in many countries like USA, Canada, Japan, Korea, Hong Kong, Greece, Egypt, and so on. And now I would like to introduce the list of these conference papers. So if you have interest, you can see the list here and download from IEEE library. This is a list of 7 my first conference papers. And this is a list of from number 8 to 15. So here we list 15 conference papers. For the patents, we have submitted 1 patent to US Patents Office and 1 patent to Korean Patents Office. And we have some more patents that are on progress. This is the name of the first patent submitted to Korean and USA Patents Office. And this is all of my achievement report. I would like to say many thanks to IITA organization for giving me these opportunities. And also I would like to say many thanks to my advisor, Professor Lee Sang-guk. Without his help, I cannot achieve something like this. And thank you very much for your listening. Thank you.
Good morning, everybody. Finally, we're on the track. The next 15 minutes are going to be pretty much about me. So let's please bear with it. My name is Junaid. I am from Aju University doing a PhD in ICT, Information Communication Technology. I've been here for 3 years. And I'm gonna take you through to some of the introduction to my professor, my research area, and some other stuff. Well, I'm going to be pretty quick in skipping the boring stuff, so just keep with me. My professor is Professor Park Seung-kyu. He's got a huge experience in different organizations, got a PhD from France, and nowadays he's just stepped down from the deanship of the Aju University Computer Science Department, so he's a pretty experienced professor. My areas of interest includes autonomic computing. Well, since it's a big domain, so I cannot name like all the things. It's been a long time, and but sure, I'm going to take you through some specifics. Some component, service, and plugin-based software development. Pretty much a step further from OSGI and other service-based environments. Dynamic adaptation and support for dynamic availability. It has to do with the mobility and the context exchange between the access points and the gateways. Software testing techniques for ubiquitous computing. Nowadays, I'm dealing with software testing techniques for ubiquitous computing. Well, pretty generally, I don't have like complex graphs to show you or things like that, but just generally. In autonomic computing, the essence, the hot application area nowadays, this area, mind you, was started by IBM in 2001. My research interest includes the self-management, how systems manage themselves. And I mean, as the size of technology is growing every year, it's becoming twofold every year, so the cost is going up. So for that reason, to bring the cost down, we deal in self-management. Autonomic versus automatic. Well, it's a pretty tricky question, but I'll try to answer in this presentation. What is the difference between autonomic and automatic? Automatic things are mostly rule-based. We already defined them all. Well, this is the thing. If this happens, this will happen. And we may put like 5,000 if statements there. But autonomics are like, they pretty much have to build their own rule base, right? We give them just a scratch thing, and they build onto that. The autonomic part. FCAPS, pretty old concept, FCAPS, of self-management, fault, configuration, accountability, performance, and security, versus modern IBM's model of autonomic computing, including self-healing, self-fault management, and things like that. FCAPS was working pretty much for the wired and the system with low dynamicity and mobility. But since the mobile computing and ad hoc networks has just gone leaps and bounds, like pretty far ahead. So the IBM proposed that, well, we need something more than that. So the autonomic computing is regarding that area. Some enabling technologies are also in my research interests. The identification of the fault signatures through immune systems, that was actually my master's thesis. Service discovery and composition, probably the backbone of autonomic computing and ubiquitous computing. The visible automation at the front end, but what the user sees and experiences is to do with service discovery, and composition is when so many services, they come together and being provided to a user. So pretty much that stuff. Context awareness and transportability. Many of us are pretty aware of context awareness and transportability, like what to capture, why to capture, and how to transport it, how to use it at the next level, next stage, next gateway, where the user is going to go and how, which part of it will take to the next location. Well, that's it about transportability and context awareness. This is some of the diagrams that I put in my papers, and they accepted that. It's a bit like this diagram over here shows that some metadata is transferred. Metadata is some information regarding a user, some raw information, not defined like, oh, these are the parameters we have to pass. Some metadata is transported from one gateway to another as the user moves. That architecture is the one I proposed in my recent publication, that between a real-time operating systems and the gateway software, there's a self-management layer. Many of us are aware of OSGI and its service-based environment, that there are a lot of services in this area, a lot of services. And there are many-to-many relationships between the users and the services. But if we just take it, if we consider it in the real-time scenario when the users are connected and getting the services, it becomes really complex. The consistency is not there. Say, for example, in time T1, a user was using a service of state S1. But in time T2, it's not necessary that the service state remains the same. It can be changed, but the user had no idea. And I should go to the next slides. My educational qualification. I did my master's from Maju University. Thanks very much for IITA. And before that, I did my Bachelor's of Science in Software Engineering from Hamdard University, Pakistan. Nowadays, I'm doing my PhD in Maju University. I have done some research. I have some research experience and some industry experience, but not a lot, because as I finished my bachelor's, I just picked up by IITA. They're pretty smart people. Thank you very much.
Thank you very much.
Oh, that's not it.
Hello, everybody. I'm Julius. I'm from Kyunghee University. and I'm working in image processing lab. So I'm from Bangladesh. So thanks IITA to give me the opportunity to say about the achievement report. So my achievement is not much high, so it will not take much time to describe. So, but I was confused what to include in this slide, so maybe I will skip most of the parts. So this is the organizations. So I complete my BS degree from University of Dhaka, Bangladesh, in 2000, and completed the MS degree from the same department and university in 2002. So I am pursuing PhD from March 2004 in Kyung University. My professor name is Professor Okesem Che, and his continuous support helped me to come in this stage. So after completing my MS, I joined as a lecturer in Department of Computer Science at that is same university, and I am in study leave there. And before joining there, I worked as a software engineer in Information Technology Division of Islami Bank Bangladesh Limited. So these just some awards that I received, and this is the publications. So I think this is enlisted in achievement report. So I need not to mention about that. So I do like to mention about this is the conference paper, and this domestic paper or some other domestic journals, and this is my research area. So it's a little bit confusing for the people because I am working in image processing lab. So first topics, that is my main focus, but during MS and when I was in Bangladesh, I was working in mobile ad hoc network. So I am continuing that research also. And I am working in medical image processing with 3D reconstruction of tooth and its segmentation. And currently I have been involved with face detection, segmentation, and warping. So this is the these slides just describe what is the moving object detection or automated video surveillance. So that is not clear. So main in case of challenges in video surveillance, these are the challenges. So I am working with this one to illumination variation, dynamic background, and camera motion. So these are the three main points that I am trying to solve. So these slides just show the challenges why video surveillance research is going on. And so this is the overview of my approach. So I am going to skip this. So these are the results. So in case of routing in mobile ad hoc network, I am concerning with three things. One is optimizing the routing cost as well as extending the lifetime of routing. And I am also concerning about the mobility of nodes. So in my research, I used these three parameters and propose an approach which will optimize these three things to achieve the highest lifetime as well as the highest total transmission of packets. So this stuff I need to skip. Okay. And this is the 3D tooth segmentation as well as reconstructing the model. So this is, in this topic, I worked to segment the segment tooth from 2D CT slice and use that segmentation result to reconstruct the tooth. So that will help the dentist to have the idea about the 3D structure of tooth. So this will be the input image and sorry. And this is the output. So from 2D CT image, this will be the 3D reconstructed tooth as well as the mandible. And I said now I am working in face segmentation. So after the segmenting the face, that is this location, and using that location, we are trying to warp that is changed according to some target face. So this will show if that is some sort of used for some sort of funny application. So this is the source image, but the shape of the image should be transformed using this target face. So there is some changes. So this is not the best possible result, but if we use some more feature, that will be there will be more similarity between these two. And this is also another warping. So this face is so using 5 feature point, this is transformed to this result. So these are the steps I am working with. So if you have interest, so I will be glad to know that. And that is all from me. And thank you very much for keep patience.
Again, 3,300 to Mr. Lo Min Chuan. 300,000 won is awarded 1,000 won is awarded to Mr. 100,000 won is awarded to Mr. This time, 1 million won is awarded to winner of the grand prize.